TechDaily.ai, your source for technical information. This deep dive is sponsored by StoneFly, your trusted solution provider and advisor in enterprise storage, backup, disaster recovery, hyperconverged in VMware, Hyper-V, Proxmox cluster, AI servers, and public and private cloud. Check out stonefly.com or email your project requirements to sales@stonefly.com. Okay, let's unpack this. Today, we're diving into something pretty crucial in cybersecurity, especially concerning Windows systems. We're talking about how attackers manage to stick around, maintain access even after you reboot or log off.
Yeah, persistence. It's fundamental to how attackers operate once they get that initial foothold.
Right, because getting in is one thing, but staying in is another game entirely.
Exactly. And it's kind of fascinating and worrying how often they just use Windows' own built-in features to do it. It's not always some complex exploit.
So they're twisting legitimate tools.
Often, yes. Clever manipulation of everyday functionalities.
Okay, so when we say persistence techniques, what are we actually talking about? Like, in simple terms.
Basically, these are just the methods attackers use to make sure their malicious code or their access survives things like restarts or logouts. The goal is always to have a reliable way back in without having to breach the system all over again.
And this isn't just theoretical, right? I mean, if they pull this off, the impact could be pretty bad.
Oh, absolutely. Successful persistence means they've essentially set up shop on your system.
Right.
From there, they can steal data slowly over time, spy on users, or, eventually deploy ransomware. It's about maintaining that control for whatever they plan next.
Okay, serious stuff. So our goal today is to explore some of the common ways they establish this foothold on Windows. We'll look at how they work and, maybe more importantly, how you might spot them.
Exactly. Generally, you see things like messing with startup scripts, abusing scheduled tasks or system services, and making sneaky changes to the registry.
Let's start with scheduled tasks. I use that for, running backups or something. How do attackers misuse it?
Well, that legitimacy is exactly what they exploit. The task scheduler is built for automation.
Right.
Attackers just create their own automated tasks to run their malicious code, maybe at a specific time or, very commonly, whenever any user logs on. Tools like Shtasks make it pretty easy.
Okay, we have an example command here using Shtasks. Can you walk us through that? Shtasks create TNT 1053005.
Sure. So Shtasks create just tells Windows, hey, make a new task.
Okay.
TN 2105300 gives it a name. Attackers might use something less obvious, maybe something that sounds like a system update task.
Great, try to blend in.
Exactly. Then skull on logon, that's the key part here. It means run this task every time someone logs in.
Every single time. Wow.
Yep. And trcmd.exe, ckelsey.exe, tells it what to run. In this example, it's just launching the calculator, calc.exe. But for an attacker, that would be the path to their malware or script.
So calc.exe is just a placeholder for something nasty.
Yeah. Precisely. And importantly, there are ways to detect this. Systems can monitor for processes interacting with the task scheduler service in unusual ways.
Good to know. And I assume you can remove these tasks.
Oh, yes. There's a corresponding command, like shtasks delete tn t105305f to get rid of it, assuming you find it, of course.
Okay, so that's scheduled tasks. What about just creating a new user account? Seems almost too simple.
It does seem simple, but it's effective. If an attacker can create a new account, especially an admin account,
they just walk back in the front door.
Pretty much. It gives them a persistent, easy-to-use entry point. Could be a local account or even a domain or cloud account if they compromise that level.
And the example here uses PowerShell. New local user, Dej name T1136. No password. No password. That seems bold.
It's direct. Creates a local username T11386 instantly without needing a password. Risky if found, yes, but very quick. They could then just log in with that username. And again, systems can watch for unusual account creation events. Specific security rules often look for new user accounts being made or enabled.
Makes sense. And deletion is straightforward, too.
Usually, yeah. Something like remove local user name T1136 would do it.
Okay, let's shift to Windows services. These are those background things that just run all the time, right?
Exactly. Services often start automatically when Windows boots up, and crucially, they frequently run with high privileges, like system privileges.
So very powerful if compromised.
Very. Attackers might create a whole new malicious service, or, more subtly, they might hijack an existing legitimate service.
How do they hijack one?
They can modify its configuration, particularly the binary path. That tells Windows which program file the service should actually run.
I see. So you change the path to point to your malware instead of the real service program.
Precisely. Tools like sc.exe or just editing the registry directly can do this.
The example shows modifying the telephony service, tapisrv. The command is ski-config tapisrv binpath, c Windows System 32 Windows PowerShell.01.exe.
Right, so that command tells the service control manager, hey, next time tapisrv is supposed to start, run PowerShell instead of the actual telephony service executable.
And boom, they have a powerful shell running with the service's permissions.
Exactly. A persistent, privileged backdoor. And detecting this often involves monitoring the registry for new service creation or unexpected changes to existing service configurations.
And presumably, you can change it back.
Yes, you'd use scaconfig again to restore the original bin path. In the tapisrv example, it would be pointing back to svcoast.exe with the correct parameters.
Okay, that's sneaky. What about this next one? Application shimming. I haven't really heard of that.
Shimming. It's less common knowledge, maybe. It's actually a Windows compatibility feature.
Compatibility. How does that help an attacker?
Well, shims are designed to let older applications run on newer Windows versions. They apply small fixes or changes to the app at runtime without touching the original code. These fixes are stored in shim databases files with an .stb extension.
Okay, so where's the hook for the attacker?
They can create their own malicious shim database. When a specific targeted application launches, Windows checks for a shim database for it.
And if it finds the attacker's malicious one?
It applies the attacker's fixes. These fixes could inject malicious code into the application's process, maybe bypass security like user account control, or hijack the app's execution flow entirely.
Wow. So you trick Windows into modifying a legitimate program for you.
Essentially, yes. The sdbins.exe tool is used to install these custom shim databases.
The example involves downloading an atomic shim x86.sdb file and then running sdbins.exe on it.
Correct. Once that malicious.sdb file is installed using sdbins.exe, the next time the targeted application runs, the malicious shim code gets executed as part of that application's process.
That's clever. Detection here would involve looking for sdbins.exe being run, I guess.
That's a key indicator, yes. Monitoring the execution of the application compatibility database installer is important.
And removal.
You can uninstall a shim database using sdbins.exe-u, followed by the path to the .stb file, and then just delete the file itself.
Okay. Now for something probably more familiar, registry run keys and the startup folder. I know you can put things there to auto start.
Exactly. This is a very old, very reliable technique for persistence. Attackers just add their program's path to specific run keys in the registry, or they drop their executable, or even just a shortcut to it, into the system startup folder.
And then it just runs when the user logs in.
Every time. And it runs with the privileges of that logged-in user.
The examples mention HKey local machine software, Microsoft Windows current version run, and run once. Those are system-wide, right?
Yeah.
Affecting everyone.
That's correct. The run key executes every time, run once executes just the next time, and then removes itself.
Okay.
And then there's the system-wide startup folder, usually at C program data, Microsoft Windows Start, menu program startup. Anything in there also runs on login for any user.
How do you typically watch for this?
This is where file integrity monitoring, or FIM, becomes really important. Security systems are often configured by default to watch these specific registry keys and the startup folder for any changes, files added, modified, or deleted.
Ah, so you get an alert if something new suddenly appears in the startup folder.
Precisely. Or if one of those run keys gets modified unexpectedly. The example here uses PowerShell to download a test file, eicar, directly into the startup folder.
Right. Invoke web request.
Yeah.
Out file C, program data, Microsoft Windows Start, menu program, startup.acar.com.txt.
Yep, and then a remove item to delete it. This simulates adding and removing a file, which a good FIM system should catch. Specific rules might even look for PowerShell being used to copy executables to startup locations.
Got it. Okay, last one on our list. Winlogon helper DLLs. Winlogon sounds important.
It is. Winlogon.exe is a core Windows process handling user logons and logoffs, and the Ctrl plus Alt plus Delete secure attention sequence.
So, central to user sessions. How can it be abused for persistence?
Because it's so central, there are points in its process configured via the registry where attackers can hook in their own code.
Where specifically? The examples point to HKLM software, Microsoft Windows NT current version Winlogon, and similar user-specific keys.
Right. Within that Winlogon key, there are several interesting subkeys. Notably, Notify, Userinit, and Shell.
Okay, what do those do?
Notify lets DLLs register to get notified of Winlogon events, like Logon. Userinit points to the program run right after login, usually userinit.exe, which starts your shell, like Explorer. And shell specifies the user's shell program itself.
So if you modify those.
You can potentially force Winlogon to load a malicious DLL or run an extra malicious executable as part of the standard login process.
The example modifies the userinit value. Set item property. Userinit, userinit.exe. See Windows System 32 CMD.exe. It adds cmd.exe.
Exactly. Normally, the userinit value just points to userinit.exe. By adding C Windows System 32 cmd.exe after it, the attacker tells Windows, after running the normal userinit, also run the command prompt.
So cmd.exe pops up automatically on login.
Yes, potentially invisibly in the background, giving the attacker another command execution vector right at login.
A detection here is similar to the run keys, watching the registry.
Yes, file integrity monitoring applies here too. Those critical Winlogon registry keys are typically monitored by default for any changes. A modification like the one in the example should trigger an alert.
And restoring it.
You'd use set item property again to set the userinit value back to just the original userinit.exe path, removing the malicious addition.
Wow, okay. This has been really insightful. It's amazing how many sort of standard parts of Windows can be twisted like this.
It really underscores that persistence is a major goal for attackers. They want that long-term access. And they'll often use the path of least resistance, which might mean abusing legitimate features.
Yeah, the key takeaway for me and for you listening is just how vital it is to understand these techniques exist. It's not just about the initial break-in.
Recognizing these patterns is the first step towards defending against them. Tools that monitor logs and system integrity are crucial here.
It definitely makes you look at everyday system functions a bit differently, doesn't it? Thinking about what else could potentially be misused. Staying informed feels absolutely critical.
And that's maybe the final thought to leave you with. Thinking beyond just these examples, what other ordinary software or system features could be vulnerable? And how can you proactively stay updated on these threats and the ways to detect them as things inevitably evolve?
A really important question. TechDaily.ai, your source for technical information. This podcast is sponsored by StoneFly, your trusted solution provider and advisor in enterprise storage, backup, disaster recovery, hyperconverged and VMware, Hyper-V, Proxmox cluster, AI servers, and public and private cloud. Check out stonefly.com or email your project requirements to sales@stonefly.com.